Hello everyone. In this video, I'm going to explain that if you have a polynomial and you want to divide with the other polynomial, how to do that. So basically, if you have something like x squared plus 4x over 4 divided by x plus 1. So we notice that in the denominator, we have two terms of the polynomial. So in this case, how can we perform this division? So before I start with the division of polynomials, I would like to review what we do in case of numbers. So if you have an improper fraction in case of numbers, what we do? So we have 4728 over 38. So we set up our long division. So 38 is our divisor. We put it outside, and 4728, we're going to put that inside. And now what we're going to do is we're going to think in our mind how many sets of 38 go into 47. So only one set of 38 goes into 47. So 38 times 1 is 38. And then we subtract. And then we take a look. So 17 minus 8 is 9. And then we bring another digit down. So we get 92. So this is what we do in case of numbers. So then we decide on how many sets of 38 goes into 92, and the answer is 38 times 2 is 76. If we go 38 times 3, that's going to be too much. So 76. So subtract again, and after subtraction we get, so this is 6, 16, and then we bring another digit down and we get 168 here. And then we think how many sets of 38 goes into 168, and the answer is 4. So 152, and again we subtract, and we are left with 16, and there is no other digit left. It means 16, which is less than 38, so it should be our remainder. And now if we think about our answer to this question, that 4728 divided by 38, so it means you get 124 full sets of 38, and then you get a remainder of 16. Or in other words, we write that 124 plus 16 over 38. So how we write our answer? So we have write our answer as, so this is our quotient, this is our remainder, and this is our divisor. So we write the final answer in this form. So quotient plus remainder over divisor. Remainder over divisor. Or in case of numbers, sometimes we just remove the plus sign, and we can just simply write this as 124, and 16 over 38 you can simplify it, divide by 2, so plus 8 over 19. Let's move to the long division in case of polynomials. So we have to divide this polynomial by x plus 1. So first thing we notice is it's an improper polynomial, so we can do our division because here the degree is 2, in the denominator the degree is 1. So we're gonna set up our division such that this is our divisor, and in the numerator we have x squared plus 4x plus 4, and we're going to arrange both polynomials in decreasing powers of x or descending powers of x. So they are already in the descending powers of x. So first we have 2 power, then 1, then constant. So let's start with our division. So first we look at the leading terms, the highest terms of both polynomials, so x and x squared. And then we ask ourselves the question that what should we multiply x with in order to get x squared? And if you're not sure, you can always take x squared and then take x, divide them together, and you get x. So we should multiply x with x to get x squared. So let's write that. And then plus 1 times x is 1x. And the next step, as we used to do in long division, we subtract. So x minus x square minus x square gives us 0. 4x minus x gives us 3x. And then we bring one term down, just like we used to bring one digit down. So we bring a term down, and next we look at again x and 3x, the leading terms, and we think in our mind, what should I multiply with x with in order to get 3x? So we should multiply by 3. So we get 3x, and 1 times 3 is just 3. And again, we subtract. And in the end, we see that 3x minus 3x is 0. So 4 minus 3 is 1. So that is our remainder. So this is our quotient. So 1 is our remainder. We cannot go any further. And this was our divisor. So we write our answer in the form. So quotient plus remainder over divisor. So divisor is x plus 1. So now we notice that we have in the end we have a mixed polynomial. So we have some polynomial without any denominators, and then we have a proper polynomial. So the degree of numerator is just 0 because it's a constant, and degree of denominator is 1. So that is how we perform the long division. Let's try one more problem. Alright, so here we have 6y squared plus 1 plus 4y cubed. And we notice that, so it's not given in the decreasing order to start with. So what we're gonna do is when we set up our long division, so we're gonna set up both the polynomials in decreasing order. So 2y minus 1, and similarly, so here we have 6y squared plus 1 plus 4y cubed. So I'm first going to write my highest term 4y cubed, then 6y squared, then plus 1. And if we think about the terms, so we have y cube term, we have y square term. So technically we should have a y term after that and then the constant term. So if you have a missing term, so it's always a good idea to write that term as like 0 times y and then the constant term. So always add a 0 x or 0 y. So using the 0 coefficients, always add the missing term. So I just wrote what I said. So always arrange in decreasing order of degree, and for any missing powers of the variable, add a term with 0 coefficient. So now we are all set. Now we can proceed. So again, first we look at our leading term. So here we have 2y, here we have 4y cubed. So we think in our mind, what should I multiply 2y with in order to get 4y cubed? And the answer is, so you need a 2, and also you need 2 copies of y. So 2y squared. So 2y squared times 2y is 4y cubed, and minus 1 times 2y squared is minus 2y squared. And in the next step, we subtract. So after subtracting, we get, so 4y cubed cancels, so 6, and this minus and minus gonna become positive, so 6 plus 2, 8y squared, and then we bring one term down, so it means plus 0y. And now we look at next leading term, so 8y squared and again 2y. So what should I multiply 2y with in order to get 8y squared? So the answer is plus 4y. So 4 times 2 is 8y squared, and again negative 1 times 4y is negative 4y. So again we subtract. So after subtraction, we notice that 8y squared is gone, and so here we get 0y and negative positive, so we get 4y, and then we bring another term down, so we get 4y plus 1. And now again we look at our leading term. So we look at 4y and we look at 2y again, and we think in our mind, what should I multiply 2y with in order to get 4y? So the answer is positive 2, so plus 2. So we get 4y, and negative 1 times 2 is negative 2. And again we subtract. And after subtraction we get 4y minus 4y is 0, and plus 1 and plus 2 we get positive 3. So this is our remainder, positive 3. So this is our remainder, and we have this our quotient, and that is our divisor. And in the end, we write our solution as, so our original question was, so 6y squared plus 1 plus 4y cubed divided by 2y minus 1. So that is equal to, so quotient plus remainder over divisor. So quotient is 2y squared plus 4y plus 2 and plus remainder over divisor. So that is our simplified version. So this is how we perform the long division for polynomial. So basically the steps are same as we do in case of numbers. And the most golden rule is, if you don't want to make a mistake, the first step is arrange the polynomials in decreasing order of degree, and for any missing powers of the variable, so you add a term with zero coefficient. I hope you like this video. So if you like this video, hit the like button and subscribe to my channel. See you next time.